Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook over.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is the beginning of trig for a trig and college algebra course. So you're probably about a third of the way through your course at this point, maybe even halfway, just depending. But now we start into hardcore trig. We start to learn all about trig and all that fun stuff. You've gone through kind of the fire of algebra, and you are forged into this new budding young mathematician. And now we go in and start talking about trig. Before we get too far though, we need to kind of build up our theory quite a bit. This is fairly common with new topics or new chapters, is that you define or you're given a lot of definitions. You need to kind of create a whole language set. So that's what the next few videos are dedicated to, is building up our nomenclature, our language, so we're all speaking the same language so that we know kind of what to expect as we move forward. So going through this first subsection is just called creating angles. It doesn't sound very appealing, but it is the basis of what we're going to be working with in trigonometry. We'll start with a line segment. So a lot of this will be review, but still good to see. A line segment is just a line terminating at and connecting two endpoints. If the endpoints are labeled P and Q, like this, then the line segment is denoted PQ with an overbar. So this line segment right here would be denoted PQ with an overbar. Some people use that line segment, that PQ overbar right there, to denote the length of PQ as well. It's not technically correct to do that, but it is forgivable because just some people do it. That's just how it is. So if you had, like, let's say a Cartesian coordinate system, and you had the 2 points 1, 1, and that was P, and the point 2, 3, that's Q, then the line segment connecting those 2 points would just be this line right here. It does not go off to infinity. It terminates at those endpoints. That's what it makes it a segment versus a line. A line, we know, goes off to infinity in both directions. All right, so that's a line segment. Then we graduate up. Well, what if one side of those line segments goes on forever? That's basically what array is. Array is a directed line segment containing an initial point, which unfortunately is often referred to as an endpoint. Anyway, I will call it an initial point, and extending through an intermediate point. If the initial point is labeled P and the intermediate point is labeled Q, the array is denoted PQ. For example, if you had the point P, and this was our initial point, 1, 1, and if we had an intermediate point Q, which is at 2, 3, let's just pretend, then the ray going through those 2 points, initiating at P and going through the intermediate point Q, it would look like that. Notice that is not a line segment because it does not terminate at Q, it just keeps going. It's not a line though, because it does not go in the other direction past P. So since it doesn't do that, it is not a line. And you might be thinking, well, what's the point of going through all this? It's because this is how you build an angle. So I'd like to have a very crisp, clean, clearly defined definition as we move forward. That's all. Now we get to a bigger definition. Again, most of this should be somewhat logical to you. An angle is the union of two rays having a common initial point. Before I go further, let me just showcase that. Here's a common initial point, P, right there. And I have two rays emanating out from that. One might go through the point Q, and one might go through the point R, for an example. All right. So that angle, or that measure between them, we would call an angle. And there are different ways actually to measure that. The initial point is called the vertex. So that would be the vertex right there. I'll label that. And let's see, what else do we have? The two rays are called the sides. Okay, so the ray PQ and the ray PR, those are called the sides of that angle. The angle formed by the rays PQ and PR is commonly called the angle QPR or QPR with the angle bar in front of it. The reason why they do that QPR, not the angle bar, but that actually, the reason why they use this angle bar right here is just to tell you that it is an angle. But the ordering on that is kind of important. The middle P there is actually the vertex. So the middle is always going to be your vertex. You would not label, for example, this angle QRP or PQR. It would always have the P in between the Q and the R because, again, the P is the vertex. So just letting you know. The notation from the last definition is used more often in geometry. When I say the notation, I mean this notation right here. In trigonometry, subsequently the rest of mathematics, angles are often labeled using Greek letters. Specifically in a trig course, theta, Theta. I know some people think I say feta, Feta, but that's feta. Anyway, like a cheese. But theta is usually what we use for angles, but you could also have phi or phi, whichever you want to call it, alpha and beta. Those also get used quite a bit. Sometimes a lambda, sometimes omegas, but more generally just Greek letters. So as an example here, I could call this angle theta. Now there's something weird about this angle, for me at least, as being a mathematician. It's not telling me which way the angle is opening. There is a direction to angles, so we just have to kind of eventually define that. I don't think that's our job right now. Actually, that is our job right now. Let's go ahead and talk about that. So, definition: initial and terminal sides of an angle. The initial side of an angle is the ray that remains static in the dynamic angle creation process. That sounds really neat, actually. So, what I mean by that is you have some initial side emanating out from P, maybe going through some point R, let's just say. That would be, let's pretend, our initial side. And now we're going to open an angle. And the way we're going to open the angle is, I'll just open it counterclockwise, so this way. And we use a little arrow there to denote that that's the way the angle opened. And we'll just open this to a different ray that goes from P through Q. And that side is called the terminal side because that's where the angle terminates. Okay. And that's what this definition basically says. The terminal side of an angle is the ray that rotates and allows the angle to increase or decrease. Now you might be asking, what the heck does it mean for an angle to increase or decrease? There are negative angles, there are positive angles, and we'll talk about the direction in which those go in a while. I suppose I could kind of let the cat out of the bag a little bit and just tell you that counterclockwise rotations are positive angles. Clockwise rotations, they're negative. And this is by convention. You cannot change this because then we'd have to change a lot of mathematics to fit your wanting desire to have a clockwise rotation be positive. That can't happen because the rest of the world would disagree with you. So for now, just be very happy with the fact that if it opens counterclockwise this way, that's a positive angle. If we had an angle that opened up, let's say this way, to where you could easily see that the lower the ray PQ is actually the terminal side and the ray PR is the initial side because of the way the arrow points there, that would be a negative angle. That's what we traditionally call a negative angle. All right, so that's it. That's how we build angles. In the next video, we'll talk about measuring angles.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.